dear students, welcome to DAV Moyle Public School. I hope you are doing great with the chapter of refraction and dispersion of light. In this video, we will be mainly discussing image formation using convex lens. Earlier in this video, we have studied about different rules and how to implement that rule to form an image we will see in this video. Now, here there are 6 cases. From these 6 cases, we will form different images by using convex lens. Now, as you can see in this picture, convex lens is there. I'm drawing an imaginary line which is passing exactly between the two surfaces. The exact center of this convex lens is known as optical center. Straight line which passes through the optical center is known as principal axis. Now, since this convex lens has two refracting surfaces, so it would have first focus and second focus. In order for a simplicity, I am not naming this f1 this focus as f1 and whereas this focus as f2. For simplicity, we will simply write focus. And what is 2f? 2f is exactly 2 times of f. Since the distance between optical center till focus is suppose f, so 2f would be 2 times of f, and this 2f is nothing but the exact radius of curvature. That is, the distance from optical center to 2f is nothing but a radius of curvature. Here also the same thing. The distance between optical center till f is the focus, and 2 times of f, that is, it is 2 times of f, that is 2f. And again, the distance between optical center to 2f is again radius of curvature. This 2f is nothing but 2 times of f. If suppose the distance from optical center to f is 1, then 2f would be 2 times of f. Here also the same 2 times of f, here also 2 times of f. Now let us discuss the first rule. The first rule says that when object is at infinite distance. Now infinite distance is a point beyond a certain range, but the rays of light are coming from an infinite distance, which means we are not aware from where the rays of light are coming, but rays are light. We are assuming that rays of light are coming from an infinite number of distance. So when an object is coming from an infinite, so this is an infinite ray of light, this is an incident ray of light which is indicated by a black line. Since this is a refracting medium, that is a transparent medium, at this point of intersection the ray of light will get converge at one particular point. That particular point is the focus, and this red line is a refracted ray. This is incident ray and this red line is refracted ray. This refracted ray will converge at this point. That point is known as principal focus. Now in order to obtain an image, I need to have minimum 2 rays. So this was the first rays and this was parallel to the principal axis. And as we have studied the rules for forming different images, whenever parallel rays of light are there with respect to principal axis, the refracted ray will always converge to one single point. That single point is termed as principal focus. Again, I have to take another parallel rays of light. So I have drawn another rays of light at this point of incidence. This red light is a refracted ray. It will again converge at this particular point. This particular point is again a focus. So as you can see, both refracted rays are intersecting at this focus point. So the image would be obtained at this intersection point. And this image would always be real and inverted, and it is a point size image. As you can see, this image, it is always real and inverted. Upside down image, real images, it can be obtained on screen, and an upside down inverted image would be obtained. So in short, you can say whenever parallel rays of light are there intersecting convex lens, the refracted ray will always and always converge at one single point. That single point would be there at that intersection point. we will obtain an image. That image would be real inverted and a point size image. Now let's discuss case number 2. Now, when the object is between infinity and 2f. So again, a convex lens is there, an imaginary line, so that I can indicate from this refraction is occurring, this point refraction is occurring in this convex lens. This point is known as optical center. Straight line is passing through this optical center, and this is f and 2f, and this is again f and 2f. This f is for this refracting surface, and this 2f is again for this refracting surface, whereas this f is for this refracting surface and this 2f is again for this refracting surface. I'm not naming at f1 and f2, it will get confused. For simplicity, I'm simply writing same 2f over here. Now, the case 2 says, in previous case, the object was at infinite distance. Now, the object is lying between infinity and 2f. So, object is placed over here. So, this arrow is an object. It is placed between an infinite distance till 2f. It is placed in between that particular location. So, object is lying between infinity and 2f. For obtaining an image, I need to have two rays of light. Now, as per the rules, whenever parallel rays of light are there with respect to principal axis, it will converge at one single point, the refracted ray. So this is the refracted ray red line. It is converging at one single point, and that is focus. And again, I have to take another ray of light. Now this is again, I'm taking this incident ray of light, and this incident ray of light I'm taking from the optical center. And as you know from the rules, that whenever a ray of light passes from optical center, it remains undeviated. Refracted ray remains undeviated. So this is the refracted ray. As you can see, this is incident ray, refracted ray. There is no bending. Both rays are going in same direction. And at the point of intersection of both these rays, this refracted ray and this refracted ray, at this point of intersection, image would be obtained. And this image would be inverted image and real image. It can be obtained on screen, and as you can see, this is a point size image. And over here, point size image would be obtained, and small size image would be obtained. As you can see, image, this is the object and this is the image. Object is larger and image is comparatively smaller. Hence, the size of the image is smaller than the object, and it is real and inverted image. In short, whenever object is lying between infinity and 2f, I have to take two rays of light. One ray I am taking parallel to the principal axis, it will pass through focus, and the other ray I am taking from the optical center, it will remain undeviated. Both the rays intersecting at this point, at the intersection point, image would be obtained, and this image would be real and inverted and smaller in size. Now let's see third case, when the object is placed exactly at 2f. Again, a convex lens is there, an imaginary line which is indicated at the center, optical center, principal axis, different terms like f, 2f for this refracting surface, this is f, and for this refracting surface again 2f, for this refracting surface this is f, and again for this refracting surface this is 2f. And now when the object, I need to place my object exactly at 2f, exactly at this 2f location, I am placing my object, and this object is indicated with an arrow. Now again I have to take minimum two rays of light. So this is the first ray of light. I am taking parallel to the principal axis. So the refracted ray would always and always pass through focus. Again I am taking another ray. Now this ray I am taking from the optical center. This incident ray is passing through the optical center, and as per the rules it will remain undeviated. So the refracted ray, it is remaining undeviated, and the both rays are intersecting at this particular point, and the intersection point, the image will be obtained, and this image would be exactly similar to the object. As you can see, both object as well as image are similar, but the difference arises that here the image is always inverted. The image is inverted upside down. As you can see, the arrow is lying upward, and this image arrow is in downward direction, and both the size of the image and size of the object are same. In short, whenever object is placed at 2f, the image will also will be obtained exactly at 2f, but the image is always real and inverted, and it is always same in size. Now let's see case number 4. Now when the object is placed between 2f and f, again for the convex lens I have to draw an imaginary line so that I can indicate from this point refraction is occurring, the exact center, optical center, imaginary principal axis is passing through the optical center. Different terms, f to f for this refracting surface, and again for f and 2f for this refracting surface. Now I need to place my object in between 2f and f. Now this is 2f and f. Now I am placing my object in between these 2 points. So this is my object, which is an arrow. Again I need to have minimum I need to have 2 rays of light. First rays of light which is I am taking as parallel to the principal axis, and it will pass through focus. As you can see, it is passing through focus. This refracted ray is passing through the focus. Again I have to take another ray of light. Now this ray of light, incident ray of light, I am passing through the optical center. It will remain undeviated, and both the rays, as you can see, both the rays are intersecting at this particular point. So at this intersection point, image would be obtained, and the image would be the image nature would be of this nature, upside down. And as you can see, object is smaller and image is relatively larger. And as you can see, size of the image is enlarged, and whatever is written over here, whenever I have placed my object in between 2f and f, the image would always be obtaining between 2f and infinity. As you can see, the last point was 2f, the infinity point might be somewhere over here. So whenever the object is placed between 2f and f, the image would always be obtaining in between 2f and infinity. This image would be inverted and enlarged than the object. Now case number 5th. Now when the object is placed exactly at f for convex lens, this is a convex lens, imaginary line, refraction from where refraction is occurring, optical center, it is this principal axis. Different terminology, 2f, f and 2f. Now I need to place my object exactly at f. So this is an object which is lying exactly at f. Now I need to have minimum 2 rays of light. This is parallel to the principal axis. This is incident ray which is parallel to the principal axis. The reflected ray will always and always pass through focus. Another ray of light, I'm passing through optical center. It will remain undeviated. And as you can see, both rays of light are never intersecting, and they will meet at an infinite distance. So the image position will be obtained at an infinite distance on the other sides of lens. As you can see, the image would be obtained on other sides of lens, and image would be at infinite distance. And it is very, very larger than the object, and it would be always real and inverted. At infinite distance, this is the object, the image would be obtaining as a real and inverted image. In short, whenever the object is lying exactly at focus, the image would be obtained at an infinite distance, the image would be real inverted, and it is very, very larger than the object. Now the 6th case, whenever in terms of convex lens, this is a convex lens, imaginary line is there from which refraction is occurring, optical center, yellow, blue line is the principal axis. Different terms like f for this refracting surface, and for this f for this refracting surface, this 2f for this refracting surface, and this 2f for this refracting surface. Now I need to place my object between focus and optical center. So I have placed my arrow over here. This is the object. And again I need to have minimum 2 rays of light. First rays of light is this. This is parallel to the principal axis. It will pass through focus. As you can see, this refracted ray, it is passing through focus. Another ray of light is this is this is another ray of incident light. Now it is passing through optical center. As you can see, it will remain undeviated as it is going. This is the refracted ray. It is going undeviated. Now, as you can see, both this refracted ray are of diverging nature. Both are going in this direction. One is going in this direction. And there is no chance of both the rays meeting, intersecting at single point. So these rays will never intersect at this particular point. So if I trace this refracted ray backward in this direction, if I trace this refracted ray in backward direction with a dash dotted lines, similarly if I have to trace this refracted ray backward with a dotted lines. Now this refracted ray, both for this dotted lines and this dotted lines, are intersecting at this particular point. So this intersection point image will be obtained, and as you can see, the object is over here and image is also here. So whenever object is placed between focus and optical center, the image will be obtaining on the same side of the lens. In previous case it was obtaining on the other side of lens, as you can see. Now in this case it will be obtaining on the same side of lens where the object is residing. Here the object was there, so image would be obtaining on the same side as that of the object, but the image would be virtual. It cannot be obtained and it would be erect. As you can see, this is erect portion. This arrow and this arrow are in same. In previous case the image was upside down, so it was inverted. Now it is an erect image and it is larger than the object. As you can see in this picture, this arrow, it is larger than this arrow. This is the object and this is the image, hence this arrow is larger than the object. So in short, whenever object is lying between optical center and focus, the image would always be virtual and erect, and it will be on the same side of the lens, and it is larger than the object. I hope you have understood the formation of image for convex lens. Thank you and have a nice day.